Live updates. A Japanese company attempts the first private moon landing. Ispace is carrying a rover from the United Arab Emirates and a small Japanese robot as it aims to demonstrate that its spacecraft can make it to the lunar surface in one piece. It could be that the spacecraft landed perfectly and it is just a communication glitch. Other less rosy outcomes are also possible. It is now about 10 minutes after the touchdown time. Ispace has cut to pre-recorded videos on its live stream. It only takes 1.3 seconds for a radio signal to travel from the moon to Earth. During the descent, the commentator mentioned that the signal from the lander had cut out. That is not necessarily catastrophic, but with the minutes that have since passed, it may be a sign that something went wrong. Silence in the control room. Commentator. They are continuing to investigate. Commentator. Everyone is laser focused right now. The time of touchdown has passed, awaiting the status. If you just tuned into the video, keep in mind that you are watching a simulation, not the actual landing. Now about 3 miles about the surface. Quiet in the control room waiting for word of the landing in a couple of minutes. Radio contact has been re-established with the spacecraft after it emerged from behind the moon. The spacecraft should be at an altitude of about 15 miles and slowing down. Another payload on the Ispace moon lander is Rashid, a small rover from the United Arab Emirates. The Arab country has a burgeoning space program. One of its astronauts, Sultan Al Nayedi, is aboard the International Space Station and preparing for his first spacewalk this week, while the country's robotic probe Hope has been exploring Mars and its moons since 2021. Ispace is highlighting the cargo it is carrying to the moon. One of the payloads, a transformable robot being tested by the Japanese space agency, JAXA, was built with the help of the company Tomy. If you grew up in the 1980s, you may recall Roby Jr., Omnibot and other toy robots built by Tomy. Now they're heading to the moon. The lander should be in the middle of its descent phase, going from 62 miles high to 15 miles. We don't know for sure because it is still over the other side of the moon, which means it cannot communicate with Earth. How the moon landing will happen. At the start of the day, the Ispace spacecraft was in an orbit about 62 miles over the moon's surface, traveling 3,600 miles per hour. It was oriented horizontally, with its main engine pointed in the direction of its motion. About 1 hour before the scheduled 12:40 p.m. Eastern Time landing, it fired its engine to drop the lander out of orbit. As it descends, the vehicle will gradually pivot to a vertical position. During the final part of the landing sequence, it will descend vertically to the surface. Company officials are highlighting their successes so far to get this point, from launch to successful operations in lunar orbit. They are also noting that whatever the outcome of the landing attempt, a second and third moon landing by Ispace are planned. The Ispace lander has already fired its engine to begin its descent. It is currently behind the moon and out of contact. There is no turning back. The Ispace webcast has begun. You can watch it in the player embedded above. The M1 lander has taken a long, slow journey to the moon. It started at 2:38 a.m. Eastern Time on Deck 11, 2022, with the launch of a SpaceX Falcon 9 rocket from Cape Canaveral, Florida. About 47 minutes later, the spacecraft separated from the rocket nearly 600 miles above the Earth and began its steady drift toward the moon. Ispace is a small Japanese company with big plans for the moon. The roots of Ispace go back to 2008 in the Netherlands. Back then, Andrew Barton, an engineer working for the European Space Agency, wanted to win the Google Lunar X Prize, which was offering $20 million for the first privately financed venture to make it to the moon. A small step toward private companies landing on the moon. A race to the moon is back on, and this time, the visitors to the lunar surface will include private companies, not just national space agencies like NASA. The first privately built visitor to land on the lunar surface intact could be a spacecraft called M1, the creation of Ispace, a startup Japanese company. Here's what you need to know about the mission. When is the moon landing, and how can I watch it? The M1 lander launched toward the moon in December, and it is already orbiting the moon. It will head to the surface on Tuesday around 12:40 p. Eastern Time. It will be early Wednesday morning in Japan. The landing site is Atlas Crater, a 54-mile wide crater in the northeast quadrant of the moon. Ispace will start a live stream at 11:40 a. Eastern Time. What is Ispace and what is it carrying? The company started as a competitor for the Google Lunar X Prize, a competition that offered a $20 million prize for the first private spacecraft to land on the moon. The Lunar X Prize expired before any of the teams made it to the launch pad, but one of them, Team Hakuto, evolved into Ispace. The company has attracted sizable investment, and Ispace plans to launch a series of commercial moon landers in the coming years. On this mission, the Hakuto RM-1 lander carries the Rashid lunar rover from the Mohammed bin Rashid Space Center in Dubai. A two-wheeled transformable lunar robot from JAXA, the Japanese space agency. A test module for a solid-state battery from NGK Sparkplug Company. An artificial intelligence flight computer. And 360-degree cameras from Canadensis Aerospace. Why is Ispace trying to land on the moon? In short, Ispace thinks there is money to be made on the moon. Ispace is one of several companies building small robotic landers to carry scientific and commercial payloads there. That market is spurred in part by NASA's current Artemis program, which aims to land astronauts near the moon's south pole in the coming years. As a Japanese company, Ispace cannot directly compete in NASA's commercial lunar payload services program, but its U.S. subsidiary is part of the team led by Draper, which last year won a $73 million contract to deliver 3 NASA-sponsored science payloads on the far side of the moon. The Draper mission will largely use a bigger Ispace lander design that will be built in the United States. Why is landing on the moon so difficult? The United States and the Soviet Union each successfully put robotic spacecraft on the moon more than 50 years ago. More recently, China has landed robotic spacecraft on the moon 3 times. However, getting there on a slim budget has proved trickier. In 2019, spacecraft built by India's space agency and an Israeli non-profit tried to land on the moon, but they crashed. That added to the list of lunar hard landings. A soft landing like the one Ispace is attempting largely requires the spacecraft to operate autonomously. There is only a short amount of time, and the ground is not going to move out of the way. It also takes 1.3 seconds for light, including radio signals, to travel from the moon to Earth, and another 1.3 seconds for a signal from Earth to reach the spacecraft. That makes any adjustments during descent tricky and dangerous. Ispace's spacecraft could have an advantage that improves its chances. The guidance and navigation software for M1 was developed by Draper Laboratory, which made the guidance computer used during NASA's Apollo moon landings. ESA to touch moon from wheels of UAE Rashid rover. 12/01/2023. 4,847 views, 86 likes. ESA enabling support space engineering technology. The very first European technology to make contact with the surface of the moon will be on the wheels of the Rashid rover, part of the Emirates lunar mission currently on the way to our natural satellite. The outer rims of this rover's 4 wheels incorporate small sample panels to test how differing materials cope with the abrasive lunar surface, including a quartet of samples contributed by ESA. Designed and developed at the Mohammed bin Rashid Space Center, MBRSC, in Dubai, the Emirates lunar mission was launched by Falcon 9 from Cape Canaveral on Sunday, 11 December 2022. Heading to the moon on a low-energy trajectory, the Rashid rover is scheduled to touch down on the lunar surface in April. The invitation to contribute to the Rashid rover's wheel-based material adhesion and abrasion detection experiment was an offer we couldn't refuse, said Aidan Cowley of ESA's XPRT, Exploration Preparation, Research and Technology, team, developing new technologies for human lunar and planetary exploration, based at the European Astronaut Center in Germany. This is a chance to touch the moon for real, to see how material technologies that we have already been working on behave in the actual lunar environment. So we will see how they interact with the regolith as the wheels make contact with the surface, as well as enduring wider lunar conditions. ESA materials engineer Hugo Lafont, located at ESA's ESTEC Technical Center in the Netherlands, has also contributed. The samples have been bonded to the outside of the rover's magnesium alloy wheels. The rover's high-resolution camera will inspect the sample panels over time, so we will be able to observe the incidence of factors such as abrasion, discoloration, and whether dust stays stuck to the samples or not. Samples on rover wheels. At approximately 10 kg in mass, the chair-sized United Arab Emirates Rashid rover is equipped with one high-resolution camera on its front mast and another mounted on its rear, as well as a microscopic camera and thermal imaging camera. It also carries a Langmuir probe to sample the plasma environment prevailing just above the lunar surface. Seeking the best possible print quality, Hugo sought the help of Orion Additive Manufacturing in Germany. This company is particularly